Hello folks, and welcome to the Converse of the Pythagorean Theorem. So today we're going to be talking about the opposite of what we use the Pythagorean Theorem for. Normally we're given a right triangle and we use the Pythagorean Theorem to solve one of the sides. Now we're going to be given all the side lengths and determine if we actually have a right angle. So you'll need your notes, a calculator, and a pencil. So just like I was saying, the converse of the Pythagorean theorem is going to tell me what kind of triangle I am. So we use the Pythagorean theorem to determine if we have a right triangle. If we don't have a right triangle, we might have a different kind of triangle. But let's start out by talking about what makes a right triangle. So we need a right angle. How do we know if we have a right angle? If it's not marked as a right angle, we can't assume it's a right angle. So we would use the Pythagorean theorem and see if a squared plus b squared is going to in fact equal c squared. So if I give you a triangle and I don't have it marked as a right triangle and I give you all these sides, can you say, well, yeah, that's for sure a right angle? Well, we can't. What we have to do is we have to prove it by using the Pythagorean theorem. So I'm going to use a squared plus b squared equals c squared, and I'm going to plug in my parts. So the legs are a and b, and this is the longest leg, so I'm going to say it's the hypotenuse. If it's the hypotenuse, if it's a right triangle, then it's the hypotenuse. So hopefully, if this all works out, this will be our hypotenuse. Okay, so then this will be 12.3 squared plus 16.4 squared equals 20.5 squared. Now, I don't know if this is going to work, so I'm going to put a question mark there because I'm going to see if it works. Now, 12.3 squared is 151.29. 16.4 squared is 268.96. And 20.5 squared is 420.25. Now, I'm going to add up these sides of the triangle, and when I do that, I get 420.25 equals 420.25. So this, in fact, is a right triangle. And if it's a right triangle, then this is where the right angle would be, and that would, in fact, be the hypotenuse. Okay, so now what if it's not going to work? What if the Pythagorean theorem doesn't work? Then what kind of triangle is it? Well, it's an obtuse triangle if the hypotenuse number that we think is the hypotenuse ends up being way bigger than the a squared plus the b squared. If it's an acute triangle, then what we thought the hypotenuse number was way too small compared to a squared plus b squared. So let's practice a few and making sure that you get these in your notes. And we have a few examples. Okay, so here we go. Is this triangle a right triangle, an obtuse triangle, or an acute triangle? Well, let's use the Pythagorean theorem to see. Now, with the Pythagorean theorem, the c squared would be our longest side because that would be our hypotenuse if this is going to work. So I'm going to do 8 squared plus 18 squared equals 24 squared. When I do that, I'm going to get 8 squared is 64, and 18 squared is 324. So 64 plus 324, and 24 squared is 576. Now, what I'm doing is I'm trying to decide if this is in fact going to work. These two added together give me 388. Oh, compared to the 576, we thought this guy was the hypotenuse. The hypotenuse is way too big. And if the hypotenuse is way too big, this in fact is an obtuse triangle. Okay, so it wouldn't look like a right triangle, it would look like an obtuse triangle, where this would be greater than 90. Okay, Let's try another one. Is this right, acute, or obtuse? Okay, well, I have the triangle has a sides of 4. 4 times the square root of 3 and 8. Well, I would have to figure out what the square root, 4 square roots of 3 would be. So if I did that, I'd plug it into my calculator. 4 times the square root of 3, and I get 6.93. Well, that's less than 8, so this is going to be one of the legs, and this is going to be the other leg. Now, I'm not going to use my decimal answer in the Pythagorean theorem. I need exact values if I'm going to find out if it's right, acute, or obtuse. So I know that the 4 is one of the legs, the 4 square roots of 3 is one of the legs. I'm going to square all of that, and will that equal 8 squared? So 4 squared is 16, and 4 square roots of 3 squared. Okay, so that's 4 square roots of 3 times 4 square roots of 3, because that means I have 2 of them. Okay, now we know how to do this because we've been working with radicals. And so we know that we can take 4 times 4 and get 16. And the square root of 3 times the square root of 3 would be giving us the square root of 9. And the square root of 9 is actually 3. So this would be 16 times 3 equals 8 squared, which is 64. 16 times 3 is 48. And 16 plus 48 is 64. And so, in fact, this would be a right triangle. Okay, let's do another example. So now I have triangle with sides of 4, the square root of 67, and 9. So let's make sure we know what the square root of 67 is. Well, that's about 8 point, sorry about that. Oh, I'm sorry. Sorry about that, guys. I was having a little bit of technical difficulties. So I'm back. Here we go. The square root of 67 is 8.18. And so it is less than 9. So I am going to go ahead and use the 9 as the hypotenuse because we always want it to be the largest. But remember, we don't put the decimals in the Pythagorean theorem. So this would be 4 squared plus the square root of 67 squared. Does that equal 9 squared? Okay, so 4 squared is going to be 16. The square root of 67 squared, the square root and the square are going to cancel out, and I'm going to be left with 67. And does that equal 9 times 9, which is 81? 16 times 67 is 83. And how does that compare to 81? Well, 81 is too small to be the hypotenuse. And if it's too small to be the hypotenuse, because it's less than a squared plus b squared, then you would have an acute triangle. Okay, so we use the converse of the Pythagorean theorem to help us decide what type of triangle we have. Okay, that's all, and we will see you again soon.